we're going to be going through some irregular cases with solving two-step equations. So you guys have been practicing solving two-step equations for a little while now, about a week and a half. So we're going to go through some funny cases now. So you guys should be very familiar with this diagram. These are the inverse operations. We have addition and subtractions, which undo each other, and then multiplication and division that undo each other as well. Now I have the golden rule of algebra, which is our scale. What we do to one side of the equation, we have to do to the other side. So we have to make sure that we treat this equation like it is a scale. We don't want to put extra amounts in one side of the scale and then not do the same to the other side, because then our scale would be unbalanced and then we cannot actually solve our equation. Okay, so right now we have PEMDAS backwards. We're calling this SADMEP, SADMEP. So in order to find the value of a variable, you have to undo the addition and subtraction first, and then you do the multiplication and division second. Now we call this SADMEP. This doesn't always work. You can use this at all periods of time unless your equation looks like this. If they look like fractions, or if they look like distributive properties, then we are not using SADMEP in order to solve these. We are using regular, schmegular, PEMDAS in the forward direction in order to solve these, okay? We can't subtract or add from a fraction. So like, for example, if I tried to subtract 16 from here, I couldn't do it. If I tried to subtract 6 from here, I could not do it because this 2 here is saying I'm multiplying 2 times x and 2 times 6. This is our distributive property. So this actual equation is not 2x plus 6. It's actually 2x plus 12. Okay, so that's one of the reasons why we can't just use our SADMEP method here, is because we have a little bit of a problem. We have these coefficients. That's what we're going to call them. We have the denominator here, and then we have this coefficient here that's kind of messing us up. So let's figure out how we're going to deal with that. So we're going to call this irregular cases. Okay, so these do not follow the same rules as other equations when we're attempting to solve them. But what we're going to be doing is following PEMDAS in the forward order, the regular order for these problems. So why is this happening? These are, like I said in the last slide, this is distributive property problems, and they're hiding, right? So for example, x plus 16 divided by 4 is equal to 10 is the same as 1/4 times x plus 16 is equal to 10. So they're just hiding, which is the reason why we can't just solve them like with our regular SADMEP method. So we're going to solve this one together, and then these are the types of problems you're going to be seeing on your practice today. They're all going to be solved in the exact same way, so just pay attention to how I'm solving them here. So I have x plus 16 divided by 4 is equal to 10. The first thing I'm going to do is identify the operations that are happening. I have a division here, which is why I have this bar. So I have a division here, and then I have an addition. Okay. Now the opposites of those are multiplication and subtraction. So those are the things I'm going to be actually doing. I'm going to be multiplying and I'm going to be subtracting. So now we're going to do those operations. So I'm multiplying by 4 on both sides. So now I'm going to rewrite. This is going to end up going away. I have 4 times 1/4 is 1. So remember, I don't have to write the 1x, but I could if I wanted to. And then I have x plus 16 is equal to, my new amount on my right side is going to be 40. And then I'm going to go forward and I'm going to subtract, like I said. I'm going to subtract. And then I end up getting x is equal to 24. That is my final answer. Now, the best thing that you can do is always check your work. If I plug 24 into my original equation, so I have 24 plus 16 divided by 4, it should be equal to 10. 24 plus 16 is 40. 40 divided by 4 is 10, and this works out. Okay? And we're going to do one more, which is the second style of problem that you're going to be seeing on your practice. We have, for example, we have 2 times the sum of x plus 15 is equal to 12. What we're going to do first is identify the operations that are going on. Here I have a multiplication, because remember, a distributive property is a multiplication, and then I have an addition problem here. I have multiplication and addition. So I'm going to identify what the opposites are. I have division and subtraction, and then I'm going to do those two things that I just identified, division and subtraction. So I'm going to rewrite my equation. I'm going to divide by 2 on both sides. I'm dividing by the value of this coefficient. And that's going to make this go away. It's going to make this go down to 1. That is, it is reducing down to 1. So I really have 1x plus 15. I don't have to write the 1 if I don't want to. It's totally okay if you do. And then I have 12 divided by 2 is 6. So my new right side is 6. And then I'm going to do the second operation that I identify, which is subtraction. And I'm going to subtract 15 from both sides. And I'm going to identify my final solution, which is -9. And it's always very good to check your work. So I'm going to plug this back into my expression. I have 2 times, oop, that's terrible. Jeez. Oop. I have 2 times -9 plus 15. So what's -9 plus 15? -9 plus 15 is 6. Okay. And that should be equal to 12. So -9 plus 16, like I said, is 6. 6 times 2 is equal to 12, which is true. Okay. This is true. That equals 12. And this checks out. Okay. Please feel free to contact us with any questions, comments, concerns, issues. If you have any problems or need any more extra help, please feel free to contact us. And you will have a great end of your week. See y'all soon.